so let's get started on some questions. So we've got here an arrow is shot at 40 meters per second at an angle of 45 degrees above level ground. So we're going to do A on this page. Draw a diagram showing the trajectory and initial velocity vector. So, alright. So it gets shot straight up in the air like that. I'm just wondering. I'm going to say it just kind of goes down like that. I know it's really bad, but for this question, all we're really concerned about is it meeting like this point before it starts descending. Yeah, because down here we start talking about maximum height. Actually, I might just redraw that because I'm not too happy with that little drawing. I might just clear the whole page. Cool. Alright. So we're going to say it goes up like that. Alright. Yeah. So we've got 45 degrees. It was shot at. And the initial velocity, so just a u, because they're not giving us a vertical or a horizontal component, is 40 meters per second. Alright. And then this is kind of like the halfway point where it starts going the other way. So we've shown the trajectory. Just put in arrows just in case. And the initial velocity vector. So this is the initial velocity vector here. The one that I draw very poorly. Okay. Now we need to calculate the horizontal and vertical initial velocity of the arrow. So we'll probably do it on this page as well. Call it B. I don't know how to do all the letters. Sorry about that. Okay. So you might be thinking, okay, how on earth do we calculate UY and how on earth do we calculate UX? If you've already started this, then terrific. Put it in the chat and that will be checked. But yeah. So this is being fired, and UY is opposite this angle, okay? This is the hypotenuse, so think of it like trigonometry, SOHCAHTOA, and this is adjacent. So to calculate UX, that's our adjacent, so we're going to be using cos. So cos uh, 45 degrees multiplied, oh not multiplied, sorry, that was a mistake. Cos 45 is equal to UX divided by 40, because that's our hypotenuse. And now we multiply both sides by 40 to get UX by itself. And we are left with a number I need to plug into my calculator, but put it into the chat if you've calculated this. So cos 45, and also make sure if you're doing methods or specialist and you're using a graphics calculator, make sure it's in degrees, not radians. Yep, so you should have gotten an answer of 28.28. And that's in meters per second because we have to use the same units. Okay? And now it's going to be very similar for uy, but this time we're dealing with opposite and hypotenuse, so we're going to use sine. So sine 45 is equal to, what's her name? uy over 40. Then once again you multiply both sides, and you will find that uy and ux is the same, 28.28, and that's just because that's the way the math works. We just happen to get both the same answer. And if you wanted to check this and like do some of the Pythagorean theorem, then by all means check, but you will end up with 40 if you were to do so. But yeah, so 28.28, that's ux, and it's also uy. Okay, now using that, we now need to calculate the time of flight of the arrow. So we're going to go over here, see the time of the flight of the arrow. So for this, we are going to need the formula Vy is equal to gt plus uy. Now, because we do not know what Vy is, we are going to say that it is 0, because initially Vy is nothing, all right? And we're just going to use the initial velocities that we have, but our final velocity we do not know. So Vy we don't know, Uy and Ux we do know, but we don't need Ux, we just need Uy. So we're going to put 0 is equal to 9.8 times t plus uy. Oh, and I just want to say as well, this is like an approximate value. I rounded that. So just make sure you have the curly equal signs. Plus uy, which is 28.28. Okay, and then we're going to rearrange, so this is going to be negative 28.28. Which is equal to 9.8t. Now you're probably thinking, hey, we're going to get a negative answer. Well, remember that gravity is actually a negative value, so we're actually going to end up with a positive value. And even if you did end up as a negative value, just negate the negative and just treat it as a positive. But in this case, we know that gravity is normally negative. So negative 28.28 divided by negative 9.8, that's going to be 2.8, I'm going to round it to 2.9 seconds, 2.89 I should say. Always round to 2 decimal places if they don't specify what you need. Alright, next we need the maximum height of the arrow, so we're going to do it on this page as well. So the maximum height. This is where we need, where is it? Yeah, sorry, I was just looking at my little note there. So we've got v squared y is equal to 2g SY. SY is what we're trying to find because they're saying horizontal range. Oh wait, no it's not. Is this the right formula then? Oh, sorry, I was looking at the very last one. I was meant to be looking at the one above it. Sorry if I just confused you guys. Calculate the maximum height. Yep, then that's fine. SY is fine. Because height is dealing with the y direction. So we need to find out what that will be. So the reason why we're using this formula, and I'll just say why in a second so I don't get muddled with my words as I write. At the maximum height, uy and vy is equal to 0 at this point. Reason being is because the velocity slows down so much to the point where it comes to a full stop in the air and then it starts to descend. So uy and vy are equal, which is 0. Okay, so this is going to be 0 and this is going to be 0. So let's... Oh, actually, is that fine? Didn't write it in my note. I've just got down here in my note that only Vy is going to be 0. But the thing is, if both of them were to be 0, then you'd find that Sy is going to be 0 in the end, because you can't divide 0 by anything. That puts us in a bit of a pickle. A little bit of a pickle. Just quickly see if there's another way we can figure this out. I think we'll just make Vy 0. Because that's what my note said, and I didn't write the justification for it. But I think, just thinking about it, I mean, logically, Uy would also be 0 at that spot. But it can't be, for the sake of math. So... I think we'll just use the Uy that we have. And then we'll just leave Vy as 0. I think that's what we'll do. Because then we've got 2 times 9.8. And if this is incorrect, then it will be put in the comments. Or you guys can figure it out and then share amongst yourselves. Multiplied by Sy, which is what we're trying to find. Plus U squared Y. So that's going to be 28.28 squared. Alright. And then we're going to move this over here because we need to get Sy by itself. So I'm just going to quickly calculate what that value is. That's going to be 799.75, but that's going to be a negative because we're moving it over. Oh, it's actually be 0.76. And then we've got 2 times 9.8 times Sy. Yep, and then we're going to divide the other side by 2 times 9.8. So then we're going to end up with SY is equal to a number, and that number will be okay, we're thinking here negative 40, but once again we can't have a negative distance. We're just going to negate the negative. I'm going to say 40.8. So apparently, according to our math, at 40.8 meters high, that displacement, that's when we reach our max height. Now let's do E. All we need for this one is displacement in the x direction is equal to the initial horizontal velocity multiplied by time. And hopefully you guys can read that. So that's just going to be equal to 28.28 multiplied by 2.89, so 2.89, oh, it's literally right there, yep, 28, yeah, 0.28 times 2.89, and this will give us our horizontal displacement, yeah. Yep, so our horizontal displacement will be 81.73 meters. If you have any questions about this question, feel free to pop them in the chat. Otherwise, we will move on now.